Hello, right now I'm talking to Hanan. He's with the volunteer coordinator for the AANC, for the convention itself and volunteering. Could you tell me more about it?
Sure. Well, we're expecting roughly between 1,000 to 2,000 people to show up here today. But we have a lot of activities. We have a few activities that are designed for children and families with Vivian White and Project Astro, building your own planisphere, which is your own star chart to find stars, and people can build them and take them home. And we have wonderful lectures from NASA and Berkeley discussing the latest news in astronomy. And we have here several planetarium shows going throughout the day showing the night sky, the constellations, 3D fly-throughs, the solar system, so lots of exciting stuff like that. We have about, I think about 20 telescopes set out around so people can throughout the day do solar viewing, as well as during the night we'll be looking at galaxies, globular clusters, and just planets, so just lots of activities for everyone.
Okay, hello, this is John Bessire. I'm talking to John Fiske. He's from SMCAS, the San Mateo County Astronomical Society. Could you explain more about what the society is?
Well, the society is a local amateur astronomy club, and we're called a society, but really we are a club, and it's open to the public. Anybody can join for $25 a year, and there are benefits. And mostly what we are is a public outreach organization. That is, where the design or the mission is really to try to bring the joys of astronomy and the wonders of astronomy out to the general public. So we meet here monthly here at CSM, and we have a good time at our star parties, and we have speakers that help improve the astronomical education and knowledge of our membership and anybody else who chooses to attend.
All right. Also, could you explain about what these posters are?
Oh, sure. Well, this one is a very lovely poster produced by Lockheed Martin and Marietta Company. This is a photograph taken by a satellite of the solar corona. And so what we're looking at here is a small, very small portion of the sun. And these huge streamers here are bands of very high temperature gases, and they are following, the gases are magnetically charged, and they're following, or electrically charged, excuse me, and they're following the magnetic field of the sun. And if you were to put the Earth in this picture, if you could, it would be just simply a very tiny dot. So the Earth would fit way inside one of these little bands. What that indicates is that these coronal streamers, that's what they're called, are absolutely huge relative to the normal scale of things that we see.
How hot do these get?
Oh boy, I don't know, but what we're talking about is several million degrees centigrade, or an absolute, so hotter than anything on Earth here, other than possibly inside of a hydrogen bomb when it explodes.
Okay. Also, they create magnetic fields that interfere with the Earth's communication.
Yes, well, what the sun does, well, essentially what we're talking about here is a storm on the surface of the sun. And periodically, not on a regular basis, what the sun does is the storm sends off charged particles, sends them off into space, and some of those charged particles will interact with the Earth's atmosphere and disrupt communications. They also cause the aurora borealis up in the northern latitudes and the southern equivalent, and so the sun very definitely affects our weather patterns and communications and gorgeous nights.
Could you also talk about the other poster over here?
But okay, this is also a poster from Lockheed Marietta, and it refers to 10 years of science done by this particular satellite, which is designed to look at the sun, the solar corona, that is the atmosphere of the sun, and determine what it's made of, how hot it is, and all kinds of other neat things about it. So this poster summarizes 10 years of research, and I'm not a specialist in solar physics, and so I can't tell you the details of it.
Hello, This is Mike Koop from FPOA. That's a Fremont Peak Observatory.
That's correct.
Association.
Yes, it's in near the town of San Juan Bautista, which is just south of Gilroy. There's a permanently mounted 30-inch telescope there that the public can go out and use on. It's open most Saturday nights when it's not the full moon weekend. So check the website, fpoa.net. But we're here today for AstroCon 2007. We're celebrating the opening of the new planetarium here at the College of San Mateo.
The acronym for SETI stands for the Search for Extraterrestrials Intelligence. And we actually at the SETI Institute do much more than that, because we're actually looking at the whole range of astrobiology, the science of where life came from, where it may be going, and where we might find it in the universe. So we have 90 scientists working on over 120 projects in that area, part of which is actually looking for the extraterrestrial intelligence. What we do there is we're looking for both radio signals and light signals that might indicate an intelligence beyond Earth, but we're also doing things like working on the oceans of Europa. Could there be life on those oceans, in those oceans? Working with the Mars rovers, working on Peter Janskens, who just moved aside here, works on meteorites. So we're working on all sorts of aspects of astrobiology. And what we're actually doing here today is we're hoping to promote our membership organization, which is Team SETI, which the funds that come in through our membership organization go directly to the scientists and supporting the scientists. So we're hoping that people that are interested in this area would actually sign up and support us, because we're basically a misconception is that we're government funded. We are not government funded. Many of our scientists in the Carl Sagan Center for the Study of Life in the Universe do get NASA grants or National Science Foundation grants. But especially the SETI Science, our education and public outreach, which is our third center, is not funded by the government. So we are looking for individuals to help us fund the science that we're trying to do, and signing up for Team SETI is a good way of doing that. Another thing that I'd like to promote is we have a weekly radio show that we do on science, astrobiology, and skepticism. That's hosted by our senior astronomer, and we have that available on our website every week, and it's also podcast, so you can find out more about science and the SETI Institute from listening to our radio show as well.
A lot of people get SETI Institute and the SETI at home mixed up.
Yes,
Can you explain that?
Yes, actually, I find it kind of interesting because SETI at home has been around for a long time. I've had it on my screensaver as well. That's a UC Berkeley project. That's not a project at the SETI Institute. And I find that we're actually doing the opposite of what SETI at home does. What SETI at home does is it takes data from the Arecibo telescope, which we have used for SETI, but it takes data that's being used for other astronomical radio astronomy projects, and then it searches through that data that somebody else has gathered and looks for signals. What the SETI Institute does is that we actually target specific stars we think are likely places for life to be, and we do our research in real time. So we're actually looking at a star in real time to see if there's a signal coming from it. And that way we can verify the signal immediately. If we find something interesting, we use other telescopes in the world to try and verify it immediately and see if it is in fact terrestrial in origin, which so far it has been, or if it could be possibly of extraterrestrial origin. The new telescope that we're building right now, that we're going to be dedicating very shortly, is going to be doing exactly the opposite of what SETI at home is, because we're going to be able to use this telescope 24/7 for doing SETI searches, which is really exciting because we've only been able to use Arecibo for 5% of the time in the past. So we'll be able to do SETI all the time, but our telescope will also be able to accumulate data for other radio astronomy projects that then they can be using at the same time we're doing our SETI searches. So we'll be sharing our data out the way that other people share their data for SETI at home. So it's sort of exactly the opposite of what SETI at home is doing. And so it's just more ways that we can be doing the search in cooperation with these other projects like SETI at home.